capacitor in DC circuit, capacitor color coding. Network of capacitors. 3 capacitors are connected in series as shown in figure 1. Work out the value of equivalent capacitance in the circuit in terms of C. Circuit of figure has been appropriately modified, inserting capacitor C in place of short circuit. Now, work out the equivalent capacitance of the circuit in terms of C. When a charge Q is applied between the two diagonally opposite corners A and B of a skeleton cube of 12 capacitors, then the charge will get distributed as shown in figure. Work out the value of equivalent capacitance of the circuit.
In this exercise, we make physical identification of the most popular electrolytic capacitor largely used in modern electronic circuits. We pick up a 1000 microfarad 25 volt miniature electrolytic capacitor for our work. One of the connecting lead appears longer and the other shorter. Electrolytic capacitors being polarized, the longer lead is to be identified as positive terminal and the shorter lead negative terminal. Look at the white mark on the body of the capacitor closer to shorter negative lead of the capacitor. Next, we move to identify the arrangement of internal battery connected to resistance range of the multimeter. Two small batteries of 1.5 volt are connected in series to make up around 3 volts in this range. Don't fail to identify the positive end of the internal battery is connected to negative black test rod of the multimeter, and the negative end of the test rod of the multimeter. Identify this black terminal is connected to the positive terminal of the battery. The red terminal, red test rod connected to the internal terminal of the battery. Battery voltage is around 3 volts. Then 11, 12. Here is a demonstration for testing a capacitor using the multimeter on the resistance range. The capacitance value is 1000 microfarad, working voltage 25 volts. First, we conduct the test using analog multimeter set at resistance range. On connecting the capacitor, the small battery in the multimeter charges the specimen and gives an indication of charging current. The charging current is gradually decreases and tending towards zero value within about 40 seconds. Here is an arrangement, a demonstration to test the holding capacity of the charge of 1000 microfarad condenser. We now use a source, 5 volt source, to charge the capacitor. The voltmeter set at 5 volt range has been permanently connected across the capacitor. Now we switch on. The capacitor has been charged permanently by 5 volt supply, giving an indication of more than 5 volt. Now we switch off the source and thereby allow the capacitor to remain with its charge. Switch off. The charge on the capacitor gradually decaying towards 0 volt. The time taken is faster, looks to be faster. That means the retentivity of the capacitor is tested by this experiment. The only thing we have to note is that it is not an ideal experiment, as the internal resistance of the voltmeter, which has been permanently connected, is discharging the capacitor.